Uncivilized Vitality anatomy playlist. We're going to go over, we're getting inside the thorax. On this video, we talked about, at least one of the videos talked about the thoracic wall, the thorax being the upper half to third of the torso. Then you have the abdominal region and the pelvis. And inside the thorax, you're going to find, which is mostly closed off by the neck and the diaphragm at the superior and inferior thoracic apertures, respectively. You're going to find two spaces laterally located. Those are going to be your pleural spaces. You'll find your lungs there. And then you got this space between the lungs called the mediastinum or mediastinum if you're from the Midwest. Mediastinum, and that's going to be divided into subspaces. So you're going to have a superior and an inferior mediastinal space, which is at that angle of Louis, that manubriosternal angle. If you drew like a horizontal plane through there, you'd have the superior mediastinal space above that and find things like your, the division at the bottom of the trachea for your right and left bronchi, the aortic arch, the great vessels. And then the inferior mediastinum is going to be divided into an anterior between the heart and the thoracic wall, the middle, which contains the heart mainly, and then the posterior mediastinal space, which is going to contain like your esophagus, trachea, more great vessels, and other such. But that's just sort of orient you. Let's talk about the middle space in this video. We're going to talk about the heart. We'll have to divide the heart up into a couple videos: external architecture, internal architecture, and probably the circulatory route, because that could be a test question on one of my tests. So let's talk about the shape of the heart. We've talked before, that is not it. Your heart is going to be shaped kind of like this. And I know that's an odd shape, sort of a bleb, but you've got your pleural surfaces and a diaphragmatic surface, a sternal surface, a base, and your heart is sort of shaped like a lumpy, truncated cone that tips over to your left. Your heart is directly behind your sternum. It's not on the left side of your chest, but you do have a little bit that peeks out behind that sternum. That's why the point of maximum intensity, PMI, which is why you feel your heartbeat more over here, or we tend to place our hand on our left chest doing like the Pledge of Allegiance or something. So it's right in the middle. The analogy would be like if you had a shield, you run into battle, you hold the shield in front of you, you don't hold it off to the right. So your heart is directly in the center of your chest. And it's kind of shaped like that. We're just doing a cutaway. You're going to have a smaller chamber up here and a slightly larger chamber. Usually when they draw these, they say below it, but in actuality, it's more anterior and slightly inferior. So antero-inferiorly. And then you're going to, on the left side of the heart, you're going to have a quite large chamber and then another one of these small chambers above. Then you're going to have between the two, it's not quite that thick, but you know, what are you going to do? My drawings are what they are. This is the septum that's going to divide the heart into the right and left. When the heart is developing embryologically, it's a kind of a long tube. And in the center, you'll find these dilatations that eventually will be the ventricles, and then the atria, and then the great vessels. And what happens is it sort of folds in the middle and starts to twist around itself, and you end up with right and left ventricles, right and left atria, and they're right next to each other, and it sort of forms into one organ. The left side of the heart is typically going to be called the systemic circulation, or that's going to be the side of the heart that pumps for the blood throughout your body. And the right side of the heart, while it's the same organ, the right side is usually referred to as the pulmonary circulatory side, because it's just going to pump blood to your lungs, which are located literally right next door. So it doesn't have to be as large, or as the contractility doesn't have to be as strong. Between the atria and the ventricles, there are going to be openings, right? There are going to be openings. And the opening on the left is going to be closed off by a two-cusp or two-lipped or two-flapped valve. And the one on the right will have three different flaps. So the one on the right is going to be referred to sometimes as the tricuspid, which is the right atrioventricular valve. And the one on the left is referred to as the bicuspid, having two flaps, or the left AV valve. Okay? This one on the left is also known as the mitral valve, right? The mitral valve, because if you flipped it upside down, it looks like that little 2-leafed hat that the Pope wears. That's called a mitre. And there's my little Pope, his little shepherd crook, right? Here, put his hand on his hip. He's a saucy Pope. He's got this little hat that's called a mitre. And if it were inverted, this little 2-flap thing would be called mitral valve. Okay, all sacrilege aside, let's keep moving on. So left and right AV valves are going to direct flow of the blood in one direction from the atria to the ventricle. The atria, or like any atrium, are the antechambers where blood starts out, and we'll go through that in a minute. For now, we're going to skip the internal architecture like the carinae trabeculae and the papillary muscles and the other structures, chordae tendineae, that hold the flaps. We'll come back to that in a secondary, more detailed video. This is about the circulation route. Once the blood's into the ventricles, it's going to exit through the start of the great vessels, and that's actually going to go in the back of the chamber, sort of toward the midline. There's going to be an opening up here that the blood will flow into. All right? And these chambers, or these openings, are going to flow through the heart. Remember, it's sort of twisted like one of those long Bavarian pretzels. The heart's going to come out, and on the right side, you're going to have the pulmonary trunk, which is going to run over to the right and the left lungs. From the left chamber, you're going to have a large vessel that comes out and curves over. All right, that's coming from the left side of the heart, and that's going to be the aorta. Now, these are going to kind of intertwine at the top of the heart. At the base of, remember, this tube runs up through the heart, right? This tube is going to be part of the internal architecture of the heart, so it flows up to the aorta or the pulmonary trunk, pulmonary artery. That's fine. It's going to split into a right and left pulmonary artery. As the blood leaves the heart in this area here, you're going to have another set of valves at both the aorta and the pulmonary artery. And these are going to have 3 little semi-lunar, so if I did a cutaway, it would look like this. There are these 3 little semi-lunar flaps, and they meet in the middle, and they've got kind of a cupped appearance. Right? They're kind of shallow little cups. And they pull together, because they're these little half moon shaped, they're called semi-lunar valves. The semi-lunar valves. And you can say right versus left semi-lunar valve as an indication of which is which, or an easier way is to say the aortic valve and the pulmonary valves. You can say aortic semi-lunar, pulmonary semi-lunar, doesn't really matter. The point is there are 4 valves. As another aside, when you hear a heartbeat, like you use a stethoscope or you put your ear to someone's chest and you're hearing that heartbeat, or you're a tiny baby in the womb of your mother, you're going to get very used to hearing her heartbeat all the time. And your heartbeat sound, the lub-dub, 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 is the sound of those valves slapping shut, closing, in response to the blood pressure. So we're going to come back to that in a minute. At the top of the aortic arch, you're going to have 3 vessels that are going to peel off. You have 3 vessels that peel off, moving from the right to the left, the brachiocephalic, the left common carotid, and the left subclavian. And we're going to go back to those in a minute. Okay? So this is the blood flowing out. Remember that arteries, the largest of which is the aorta, or the pulmonary artery, trunk. The aorta flows into arteries. Arteries flow into arterioles. Arterioles flow into capillaries, which are the microscopic, tiny little single-celled folded blood vessels that are mostly fenestrated or leaky, which is where you exchange the fluids between the blood compartment and the interstitial fluid. And then they're going to return to the heart or to general circulation through a series of small venules, veins, and eventually into very large vena cava. Okay? You have an inferior and a superior vena cava. So up here, and I'm gonna draw over this and have to erase a little bit. Flowing back to the right atrium, you're going to have the superior vena cava, and then from below, the inferior vena cava. This would be the superior vena cava. We'll go back and maybe label these. You can just pause and label on your own picture so we don't get too carried away. The veins are going to overlie some of these structures in the front. And we're going to go like that. So, you have these venous structures lying in there. This is going to be your superior vena cava, and you're going to get your left and right brachiocephalic veins. Sometimes in some books you'll see this word, innominate veins. That's not a good way, that's not a good name for them. Innominate means no name. You could just call them brachiocephalic. You're also going to get the inclusion of the azygous and hemiazygous veins here, but we're going to skip all that because this is going to get too full. So there's going to be your right subclavian and your right internal jugular, left internal jugular, left subclavian. They're going to flow back to the superior vena cava, most of the upper body, limbs, head, neck, chest, and the inferior vena cava coming from everything basically below the diaphragm will bring blood back up. Now, let's do lungs in green. So I got my lung over here. I got my lung on the right. Coming back from the lungs to the left will be a set of pulmonary veins. And then behind that body of the heart will be the pulmonary veins from this side. And they're going to end up here in the left atria. All right, so what we have is a basic diagram. Here's your heart in the middle, right? And then we're going to draw the body, which is just going to represent systemic circulation. And up here, the lungs, right? So this is how your circulation's going to flow. You're going to move from the right side of the heart. You're going to go to the lungs. From the lungs, you're going to go back to the left side of the heart. From the left side of the heart, out to the body, and from the body, or systemic circulation, back to the heart. And you'll see that it's going to cross over almost in a figure eight with the heart at the center of the circulation. I don't know why my right lung is so tiny. Little case of atelectasis, I guess. So this is how it's going to go. You're going to be in the right atria. You're a red blood cell. You're going to flow from the right atria. Let's say you're going out to your right thumb. You're coming all the way out here to your thumb, right? Does that look like a hand? Okay, there you're going to flow out to the thumb. We're just going to hit the big blood vessels just to kind of show how this goes. You're going to move from the right atria. You're going to pass the right AV valve once the atria contract. The atria relax. The ventricles are going to contract. When the ventricles contract, they're going to slap shut the AV valves, atrioventricular, right and left. It's going to be the tricuspid, bicuspid. It's going to close that. The ventricles squeeze. They can't go back up through the valve unless you have a leaky valve or a flap, in which case some blood will whoosh back through there, and when it whooshes through, on your stethoscope, you'll hear it go, I don't know if that word, that's a heart murmur. So you might have a insufficient closing of the valves and you get a heart murmur. You could have the valves not shutting at the same time because these two close, lub, dub, lub, dub, lub, dub. But you might get a split in there somewhere between the two sounds, lub, lub, dub, dub, or lub, dub, dub, lub, dub, dub. Because the sides are not coordinating at the same time. Then you get gallops and splits, but let's skip that. So you're in the AV, you're in the atria, red blood cell. You are going to take a trip out to the thumb, okay? So you're a little red blood cell. First, you're going to go through the right AV valve into the right ventricle. The ventricle is going to contract, closing the AV valve, so you can't go back through. So you're going to be forced to be ejected up into the pulmonary trunk, into the right and left pulmonary arteries. Doesn't matter which one. you are going to head over to the lungs, and then you're going to go down through another series of arteries, the lobes, and then the segmental arteries. You're going to go down smaller and smaller into arterioles until you get down around the oxygen exchange around the alveoli or the sinae at the end, and you're going to pick up some fresh oxygen because you are mainly deoxygenated on the right side as you leave the heart. That'll become apparent in a minute. So I pick up some oxygen, I've picked up some O2, maybe I've given off some CO2, and now I'm going to head back to the heart via the pulmonary veins, but now I'm going to end up in the left atria. So the left atria is going to receive oxygenated blood from the right and left lungs, and we'll talk about the right in a minute. Now from here, another heartbeat is going to contract. And remember, I'm flowing with a bunch of others. This is not a static or sequential position or process. It's constantly flowing. We'll talk about different Starling forces and fluid dynamics in maybe another video, but probably not. I'm too lazy to get that far. So that's kind of true. So back through the pulmonary veins into the left atria. From the left atria, the next heartbeat is going to squeeze the atria. It's going to open up. Remember, the same thing's happening on the right. It's going to open up the left AV valve, and I'm going to flow into the left ventricle. Now the ventricles are going to contract. Again, same thing happening on the right. It's going to close off the AV valve, unless I have a murmur, slaps it shut, forcing me up through that opening at the back of the chamber, up past the aortic valve, or the left semilunar valve. Real quick point, anatomically, like physically, the right semilunar valve is slightly left of the left semilunar valve, but don't think about that too much. Just think left and right with systemic and pulmonary. Up through my aorta. As I go around my aortic arch, I'm going to take a quick detour, for whatever reason, out of or through the brachiocephalic and into my right subclavian. And then I would go through my right axillary artery, the brachial artery, down, let's say, radial artery in my forearm. And then I get down to some arterioles out here on the digital arteries, digital arterioles, little capillaries in my thumb where I disperse oxygen to all the tissue. And then, having given up a bunch of my oxygen, I start heading back to the heart by coming up through the vein, or the small venules, and then maybe this dorsal venous arch. Maybe I slip into the cephalic vein superficially instead of a deep vein. I work my way up until I dump through this deltopectoral triangle into the right subclavian vein. And now I'm working my way back down the superior brachiocephalic vein, superior vena cava, and I end up right back where I started. Right? So that'd be the course of maybe a typical blood cell. I left off a bunch of detail, but that would be enough to get you a good answer on a test question that said, pretend you're a red blood cell and you're circulating out to the right thumb and back. If I said left thumb, you would have went out through the left subclavian artery. If I would have said right big toe, you would have had to travel up through the aortic arch, down through the descending aorta, abdominal aorta, and then you get down to your common iliacs and start moving, but we have, maybe I haven't covered that yet. So we're gonna just stick here. So this is basic heart circulation. A couple things are happening that make your heart beat. Remember, left and right are contracting at the same time. While blood cell number 1, or blood cell A, is moving on the right side over the lungs, there were blood cells B, C, and D already in the left atria moving that have been oxygenated, and they're sending their blood, their oxygen supply out to the systemic circulation. The blood that's returning from the body has less oxygen. The blood that is going out to the heart has less oxygen. The blood that is returning from the heart, from the lungs, has more oxygen, and the blood that's heading out to the body has more oxygen. I think I might have boobed that up, so let's try it again. Right side of the heart sends deoxygenated blood to the lungs. They come back to the left side, left atria, fully oxygenated, and head out to the body, fully oxygenated. And then the venous side of the systemic circulation, which is going to go through your vena cavas eventually, is going to be less oxygenated blood. So it comes back to the heart, and it just moves in this figure 8 pattern, delivering oxygen and deoxygenated blood. Systemic side, veins, the venous side of circulation has less blood, less oxygen. And in the pulmonary, the arteries have less oxygen. Don't mess that up on a test. That's a simple question to get confused. Basic architecture, got the basic valves. What else we tell you about the heart? So that's the basic circulation. Leave some comments below if you have any questions about that. And I'll do some more videos following up with the heart, especially. We got to do internal architecture and some of the structures, a little more difficult to draw. We'll go over the electric conduction of the heart in another video, a short one, and we will do the mediastinal spaces, and we'll do some lungs. So stay tuned for those.